Okay, this paper is a Year 3 nursing paper, Child Branch. A calculator is permitted in this paper. Notice that we have to adhere to certain rules regarding units and use of accepted abbreviations. It is perfectly okay to write units in full, but if you are to abbreviate them, make sure you use the accepted abbreviation. This is always on the front of the paper. It's a 30-minute exam, and there are 10 questions on the paper, each receiving 1 mark. There are no part marks, there are no method marks. And it does state here, you must write your final answer in the answer box provided, including the unit. So let's dive in. Question 1. The recommended dose for a drug is 18 milligrams per kilogram. How many milligrams should be prescribed for a child who weighs 17 kilograms? Now this is a weight-dependent question, and I can tell this because you have per kilogram as a statement there in the dosage for the child. So whenever I see per kilograms, I know it's weight dependent, and therefore I will multiply by the weight. So I have to do 18 milligrams multiplied by 17. Now I've written my units there, milligrams on the dosage and the weight of the child, but I've only really highlighted the dosage unit, the milligrams, because the weight of the child is simply a multiplier. It will not occur in the final answer. So get my calculator out. 18 times 17 is 306. So I know my answer is 306, so pop that in the answer box, and I must think about the units. But it said here how many milligrams should be prescribed, so my unit will be milligrams. So there we have question 1 done. On to question 2. You need to give 70 milligrams of a drug. The solution you have contains 50 milligrams in 3 milliliters. How many milliliters do you need to give? Now this is a classic liquid dose question, so for that we'll need a formula. And the formula I most often see is the following. What you want over what you've got times what it's in. Now what you want means what do you want to give the patient, and what you've got means what have you got in stock. So I like to think about the patient and the stock. In fact, I think of the old adage, the patient comes first, to guide me as to which number I should pull out first. And it's the 70 milligrams I need to pull out first. That's my patient number. So let's put these numbers, including their units, into that formula. I want to give my patient 70 milligrams. In stock, I have 50 milligrams, and it's in 3 milliliters. So the times what it's in 3 milliliters. Now we need to pause here because, of course, I have to think about units, not only for the answer box, but also in my working. And I always consider in liquid dose the units in the fraction part, and I need to ensure they are the same. On this occasion, they are the same. They're both milligrams, so I can proceed with my calculation. Now, to turn any fraction into a calculation, it's always top divided by bottom. So I'll be doing 70 divided by 50 multiplied by 3. And that comes out to be 4.2. So go to my answer box, put the 4.2. What are my units? Well, I've got 2 strong clues. In the question itself, it said how many milliliters do you need to give. And in my consideration of units, these 2 milligrams have, in a very real sense, cancelled each other out, leaving just the milliliters. So my units are milliliters, 4.2 milliliters. And that's question 2 done. On to question 3. A patient weighing 14 kilograms is prescribed 2 milligrams per kilogram of a drug. Each ampule contains 0.7 grams in 10 milliliters. Calculate the volume that the patient needs in milliliters. Well, that first sentence, 14 kilograms prescribed 2 milligrams per kilogram, sounds like my question 1. It sounds like a weight-dependent question. The second sentence, each ampule containing 0.7 grams in 10 milliliters, sounds like a liquid dose. In fact, both thoughts are true. It is a weight-dependent liquid dose question, and therefore I'll need to take 2 steps. The sensible first step is to multiply the dosage, in this case the 2 milligrams, by the patient's weight. So once again, I'll do 2 times 14, which is 28. And you'll notice again the kilograms is only a multiplier. It is milligrams that comes out in my answer. So 28 milligrams comes out of my step 1. That will go into step 2 because that will be what you want to give the patient number. So apply my liquid dose formula, which you remember is what you want, what you've got, times what it's in. And I'm thinking about the patient coming first, so it's 28 milligrams over the 0.7 grams, the stock strength, times what it's in 10 milliliters. But we haven't finished yet with our thinking. We can't quite get the calculator out for our final calculation because on that fraction you'll notice the units are not the same and they need to be the same to allow me to proceed. So I could either make both top and bottom milligrams or both top and bottom grams, and it doesn't matter which direction I take. I'm going to choose to convert that bottom number 0.7 grams into milligrams. So we need to remember how to convert it. Let's remind ourselves. This is the kind of diagram many students like to jot down in their examination, and I want to do grams into milligrams. Well, grams to milligrams is moving downstairs, so I multiply by 1,000. 0.7 times 1,000 gives me 700 milligrams, the new units. So I can now go back to my question, and that formula that I had unpacked can now be rewritten as 28 milligrams over 700 milligrams. Now I'm happy with the units in my fraction part, so the calculator comes out 28 divided by 700 times 10, and that gives me 0.4. So put that into my answer box. What are my units? Well, as before, the milligrams have cancelled, and I'm left with milliliters, which of course is what it said in the question. So 0.4 milliliters. On to question 4. This is a fluid balance question, and they're given as a chart with various inputs and various outputs. I'll have to do a couple of steps here. I know the fluid balance equation is input minus output, but I need to calculate the total input and the total output before I can proceed. So let's take it nice and carefully. Step 1, find the total input. Well, I've got an all intake of 580 mils and an IV input of 185 mils. So I add those two together, 580 plus 185 equals 765 milliliters. That is my total input. My total output, well, I have got a urine output of 630 milliliters and a stoma's losses output of 155 milliliters. So my total output is 630 plus 155 mil is 785 milliliters. Now I can apply the fluid balance formula, which is input minus output. So it's 765, take away 785, and you'll notice the answer is negative 20 milliliters. It's very important to record a negative sign, and in this case, if it was a plus sign, I'd have to record that as well, because it clearly says in this little instruction here that I have to get the net balance as a plus or minus. So the three items that need to go in that answer box. There's the 20, there's the unit, which is milliliters as instructed and as given here, and then there's the sign. I just written negative here, but you could have written minus VE. It's best not just to write minus, because remember we are mimicking what you might write or see in patient notes. It needs to be crystal clear. Question 5. An adolescent weighs 44 kilograms and has passed a total of 1584 milliliters of urine in 24 hours. Calculate his urine output in milliliters per kilogram per hour. There seems to be a lot going on here, so let's take it nice and steady. Because I want milliliters per kilogram as part of my answer, but I've got 1584 milliliters per 44 kilogram, I must divide that 1584 by the child's weight. So 1584 divided by 44 gives me 36 milliliters per kilogram. So I already feel that I'm halfway there. Now this is the amount that has occurred in 24 hours, but I want to calculate the rate in hours. So my step 2 will be divide this number, the 36, by the number of hours in a day to get my final units correct. So I'll simply do 36 divide 24. You'll notice I've carefully kept a track of my units, and that gives 1.5. And now my units are all combined together, milliliters per kilogram per hour, as they ask for. So that gets popped into the answer box along with those units. This is one of those examples where if you were to miss out part of your units, you would simply lose the whole mark. So do always take care with units. It's always worth writing them down as I have done so you can track through them. Question 6. A 240 milliliter infusion needs to be delivered over a period of 6 hours. At what rate in milliliters per hour should the infusion be administered? Now an infusion has a very simple formula which is rate equals volume over time. So let's use this formula to unpack the question. Well, the volume I'm going to be administering is 240 milliliters and the time is 6 hours. So I've got 240 over 6. As usual, I have recorded the units and I need to think about this. Do I need to modify those units? This is not a liquid dose question, so I have a different level of thinking to do. I want mils per hour. I've got mils per hour, so I'm happy on this occasion. No need to change any of the units. So calculator out, 240 divided by 6 equals 40. So pop that into my answer box 40 and my unit will be milliliters per hour. Job done. On to the next question. The maximum daily dose of ibuprofen for a child is 30 milligrams per kilogram per day. A child weighing 16 kilograms is prescribed the medicine 6 hourly. How much needs to be given in each dose? There's a lot going on here. You are told that the dosage is in a day, but we've got to work out how much we will give every 6 hours. So we'll have to be thinking about how many times we will be administering that dosage. You see that per kilogram part, we've seen this twice already so far in this paper. That will tell us that one of the steps will be to multiply by the child's weight. Clearly this question has several steps. Step 1. Multiply the weight to get the maximum daily dose for this particular child. So 30 milligrams times 16. I haven't even bothered to put the kilograms here because I know by now it is simply a multiplier, and that gives me 480 milligrams is what that child will receive in a single day. So step 2, I've got to think about this 6 hour business. Now I'm not dividing by 6. I have to think how many times must I go to that child during a day if I'm going there 6 hourly. So I must divide the number of hours in a day, 24, by 6 hours. And that gives me 4. There are 4 occasions. So now I can say, right, if I'm giving that child 480 milligrams for the whole day, I must divide that number by 4 to find out how much will be given in each occasion on each individual dose. So final step, divide that 480 by the 4. And that gives me 120. So I can pop that into my answer box. One of my units, well, my units are just milligrams because it said how much needs to be given in each dose. I'm only worried about the milligram part of this because these other two elements have already been taken care of, got rid of, if you will, in my working out. Question 8. A doctor has prescribed 35 I units, otherwise known as international units, of a drug. If there are 50 international units in 3 milliliters, calculate the volume in milliliters. It may not be obvious, but this is a standard liquid dose question. We have a formula for this. What you want over what you've got times what it's in. And remember, we always think of the patient number first. Well, the patient number is the 35 IU, the stock number is the 50 IU, and the what it's in 3 milliliters. So let's apply that formula. We have 35 IU over 50 IU times 3 mil. Each time we have come across a liquid dose question, we have made sure that the units in the fraction are the same. And indeed they are the same in this occasion. In fact, I didn't really have to know what an international unit was in order to be reassured that my units are the same, therefore they will cancel out, and so I can simply now move to the calculator and work out 35 divided by 50 times by 3. And that gives me 2.1. Pop that into my answer box, 2.1, one of my units, milliliters. Question 9. Now this looks really complicated. What they give us at the top is a weight estimation formula, and then a series of instructions regarding how to calculate the hourly maintenance fluid for a particular child. So let's take this nice and easy. Step 1 will be to estimate the weight of a 5-year-old child, and I will use this formula. So I will take the child's age, 5, add 4 to it, which is 9, and multiply that by 2. So I get 2 times 9, which is 18. It's very important in this formula to do the contents of the bracket first. That's what the bracket means. It says do me first and then multiply by the 2. So I've estimated that child will weigh 18 kilograms. Now these next set of instructions, it tells us that up to and including the first 10 kilogram of that child's weight, you will give them 4 millilitres for every kilogram that they weigh. If their child's weight goes beyond 10 kilograms, as ours does, then for additional kilograms beyond that 10 kilograms, we give them 2 millilitres for every additional kilogram. That's up to what will be a total of 20 kilograms. Now, this particular child does not go beyond 20 kilograms, so we'll only be looking at those first 2 lines. So I'm going to think of that 18 kilograms as being split to 10 kilograms and 8 kilograms, so I know what to multiply these top 2 numbers by. So I'll do the 4 millilitres multiplied by 10 for that first 10 kilograms. That gives me 40 millilitres. And then 2 millilitres, this next instruction, multiplied by the 8 for the second portion of that child's weight. That gives me 16 millilitres. That's the child's weight fully taken care of. So my total hourly maintenance fluid requirement will be to simply add those 2 numbers together. 40 plus 16 is 56. What are my units? They are millilitres per kilogram per hour. I have simply mimicked the units that it gave in the instruction table. Final question. You are caring for a child who is receiving an infusion. The child weighs 16 kilograms. The infusion contains 60 milligrams of a drug made up to 50 millilitres with a compatible fluid running at 1 milliliter per hour. How many micrograms per kilogram per minute is the child receiving? Now they've given us here the unit that we are aiming for, and that will be the units we put in our answer box. This is, in my opinion, the hardest question on the paper. Let's take it one step at a time. Let's convert that milligrams into micrograms so that that first part of the final unit is taken care of. Now, milligrams to micrograms, I've got to go back and think about my little staircase. Well, milligrams to micrograms, I'm going downstairs, so I multiply by 1,000. 60 times 1,000 is 60,000 micrograms. Okay, so far so good. Now, we know that that 60 micrograms is in a made up volume of 50 millilitres, but I know that this fluid will be running at 1 milliliter per hour, so I would like to know how many micrograms are there in 1 milliliter. So step 2 will be to divide by this made up volume, by the 50 millilitres. So 60,000 divided by 50 is 1,200 micrograms, and that now is in 1 milliliter. We're now ready to take care of the child's weight. We now divide by the child's weight, because that 1,200 micrograms is for the full 16 kilogram. We're trying to work out how much that equates per kilogram. So I'll now divide that 1,200 by 16. 75 micrograms per kilogram, and that's in 1 hour, which matches this part of the question, but we want it in minutes. So our final step is to divide that 75 by 60. 75 divided by 60 is 1.25. Pop that into the answer box. Remember, our units are microgram per kilogram per minute, so pop that into my answer box as well. And we're done. That was a very difficult question and will take some practice, but be guided by the units. Units is something that's been a feature throughout this entire test paper. A few final thoughts. You should have time at the end of this paper to do some checking, because if you carried out some practice papers, you should become quite efficient in running through it in about 15 to 20 minutes. I'd always advise you go back to any questions that you struggled on or any questions that you know can be difficult. For example, that last one we saw. Also, for each question, check that you have both the correct units and that units have been recorded fully and accurately as per the instruction on the opening page. And finally, it's always worth asking, from your experience, from your training, does each answer seem reasonable? Thank you very much.